All right, last example. This is a fun one. It's not too tough, but it's a new strategy, new question type that we haven't seen. A light on top of a 10-meter lamp pole. So lamp pole, light, and shines on a woman 1.6 meters tall. So let's see, there she is. Okay, she's 1.6 meters tall. 1.6 meters. This is 10 meters. And the idea is she walks away. So she starts here and she's walking away, um, like this, um, and away from the light at a rate of 1 meter per second. So this is 1 meter per second. By the way, good luck putting that into your notes. See, this is smart board magic at its finest. 1 meter per second. How fast is the length of her shadow increasing when she is 15 meters from the base of the lamppost? Well, first of all, where's her shadow? Where's her shadow? Well, it's on the ground, right? But it's not over here. Her shadow is blocked out. It'll be over here, right? There's her shadow. And, you know, when she moves over this way, the shadow will be on the ground, but maybe a little bit shorter, right? Because, uh, like that, the shadow will be a little shorter because it shines straight down, like this, right? So let's move her a little bit away from the um, lamp there, and the shadow is going to be on the ground. We'll call that maybe S, right? And what do we got here? Well, we actually have some similar triangles. I don't know if you're thinking about that, but these are similar. There's some similar triangles. Let's figure out what we're actually asked for, though, and see if we can get um, some variables going here. Because all these numbers, what do they stand for? Well, uh, what are we required? We want to find how fast is the length of her shadow increasing. So we want to find, we call this S, length of the shadow. We want to find ds dt when this distance here, the distance that she's moved, I'm going to call it L for length, is 15, right? Okay, now the problem is what formula do we have that relates all of this stuff? Notice it's not Pythagorean theorem, although there's some Pythagorean theorems here. We don't have anything about the hypotenuse. We just have, this height and the shadow and the height of the pole and the length and she's walking away. She's walking away. There she is. There she goes. She's walking away. Um, and how do we get the relationship? Well, what happens is wherever she moves, we're going to end up with similar triangles, right? The idea of the light shines and lengthens the shadow. This angle is always going to be the same. It's going to make similar triangles. So that's the key. That's the new thing. We saw similar triangles when we did the cones a little bit, but this is the key, similar triangles. So where? Okay, well there's her, right? That's S, and this is 1.6 meters. And then we have the post, which is 10, right? And then this, what's this? Well, this is L plus S, right? So then I can set up a ratio. Big to small equals big to small. Cross multiply. Feel like I'm in grade 10 again. 10s equals 1.6L plus 1.6S. Just cross multiply. Collect up some like terms. I get 8.4S equals 1.6L. I want to check my notes before I get ahead of myself. So, okay, great. Notice that if I took a derivative here, If I took a derivative, I'd have my ds dt. So I'm on the right track. Things are going well here. So I am going to take the derivative. So this is just 8.4. The 1 would come down, and then I got to take the derivative of the inside thing, ds dt. And then the derivative of this is 1.6 dl dt. Okay, that's great. Dandy. That's what I want to find. What's dl dt? dl. dl. At what rate was L changing? Huh. That was her walking away. When she's walking away by 1 meter, dl dt was 1. So that's equal to 1. Okay, no problem. So that means I can solve for ds dt is just ds dt is 1.6 over 8.4, which is about 1.9 or 0.19 rather. Uh, and therefore her shadow increases by 0.19. What's that? Meters per second? Is that meters per second? I want to point something out. Where did this go? It didn't matter, right? When we took the derivative and we started talking about rates, the length, how far she was away, didn't matter. The shadow was actually increasing by a constant rate. Didn't matter how far away she was, it was always going to increase by 0.19 meters per second. So I'm going to write, and this was a constant rate, which was surprising, I think. I think that's surprising. Okay, Danny, that's it. Give them a go. Homework is on the website.